Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Dear students, this is our course titled Advanced Physical Chemistry. I am Dr. Rana Farat Mahmood. This is our lecture number 9 and course is conductometry. Course code is CHEM 3117. Now let us start our topic. The contents are number 1, adsorption and its types. Number 2, difference in adsorption and absorption. And number 3, adsorption isotherm. And number 4, types of absorption isotherm. In adsorption we will discuss about its definition, and then we will discuss its types. Number 2, we will discuss the difference in adsorption and absorption. Okay, then we will discuss about adsorption isotherm, and then we will discuss about types of adsorption isotherm. Okay, let us go our contents. On slide number 4, we are discussing about adsorption. The definition is about the phenomena of concentration of molecules of a gas or liquid at a solid surface. The term adsorption was introduced by Kaiser in 1881. In the diagram, this is explained that on solid surface, a gas molecule are adsorbed. This is called adsorption. Basically, it is phenomena of concentration of molecules of a gas or liquid at a solid surface. Okay. In this term, we are discussing about adsorption means that the molecules of liquid or gases are adsorbed on the solid surface. Then we will discuss about what is adsorbent and what is adsorb. Okay. Then we will discuss about desorption. Basically, the term adsorption and desorption are opposite. The adsorption we are discussing is the phenomena of concentration of molecules of a gas or liquid at a solid surface. Okay, let us go over next slide number 5. Some important terms are adsorbent, adsorbate, and desorption. The adsorbent is the that solid that takes up a gas, a vapor, or a solute from a solution. Example given: silica gel, charcoal, clay, etc. The adsorbate is the gas, vapor, or the solute that adheres to the surface of solid. Example given: poisonous gases. Then this is about desorption, the process of removal of adsorbed substances from surface on which it is adsorbed. There is a diagram in which the lowest layer is the adsorbent, mean it is of solid. Then on this solid, the gas molecules or vapor or the solute molecules are adsorbed. So these upper layers are called adsorbate and the lowest layer is called adsorbent. So adsorbent is the solid on which gas molecules are adsorbed, or the solid that takes up a gas molecule. Example given: silica gel, charcoal, clay. We will see that what is silica gel, what is charcoal, and what is clay on the next slides. Here we are seeing that what is absorbent, what is adsorbate, and what is desorption. Desorption is the opposite process of the adsorption. Adsorption is the process of attaching of molecules of gas on the solid, while desorption is the process of removal of Adsorbed substances mean adsorbate, the removal of adsorbate from adsorbent. It is called desorption. And what is adsorbate? It is the gas, vapor, or the solute that holds on the solid surface. Example given poison gases. And what is adsorbent? It is solid on which gas molecules are held. Means that silica gel, charcoal, clay are the solid surfaces on which gas molecules can be adsorbed. So these solid surfaces are called as adsorbent. Okay. Now let us go our next slides. Okay. Some commonly used adsorbents means that the solid surfaces. First is silica gel, and then second is activated charcoal. It is in black color, and then alumina. It is in powder form, and then bentonite clay. It is in powder and rock form, and then zeolites. It is also in rock form, and then bagasse. It is in uh, powdery means that or some grass. It is some type of grass. Okay, now let us go our next slide where some other concepts have been given to you. Okay, let us discuss our examples of adsorption on our slide number 7. The first example is that adsorption of dye by a charcoal. If finely divided charcoal is stirred into a dilute solution of methylene blue, an organic dye. Methylene blue is an organic dye. The depth of color of the solution decreases appreciably. The dye molecules have been adsorbed by charcoal particles. Okay. In our second example is that adsorption of a gas by a charcoal. If we have a gas means we have a sulfur dioxide, chlorine gas or ammonia, and then we treat this gas. If a gas is treated with powdered charcoal in a closed vessel, the gas pressure is found to decrease. The gas molecules concentrate on charcoal surface and are said to be adsorbed and are said to be adsorbed. These are the two examples of adsorption. First is adsorption of dye by a charcoal. Any dye means a finely divided charcoal. If we stir a finely divided charcoal into dilute solution of any dye, we take for example methylene blue, that is an organic dye, and in this if we divide the finely divided charcoal and then we stir it, then the depth of the color solution decreases appreciably. This is because of adsorption. The dye molecules have been adsorbed by charcoal. Okay. In our second example is the adsorption of a gas by a charcoal. The any if we take any gas, sulfur dioxide, chlorine gas, ammonia gas, and then we treat it with the powdered charcoal in a closed vessel, then the gas pressure will be decreased because of adsorption. The gas molecules concentrate on charcoal and are said to be adsorbed. That is why their pressure is appreciably decreased so much. Let us go our slide number 8. This is about our slide number 8 is about the difference between adsorption and absorption. First is about absorption, the phenomena in which particles of a gas or liquid uniformly distributed throughout is called absorption. It is a bulk phenomena and it occurs at uniform rate. It occurs at uniform rate. Anhydrous calcium chloride. This is not calcium carbide. This is about calcium chloride. Absorbs water. Okay. In the picture, there is written that a molecule is written, and in this molecule, three other molecules are absorbed. It means that the molecules that are being absorbed are the entered in this molecule. Okay, coming to our next point is adsorption. It is a phenomenon in which a higher concentration of particles of a gas or liquid are adsorbed on surface than in bulk. It means that the molecules of higher concentration are remained on the surface of bulk. It has been found that in adsorption the molecules are not entered in the other molecules. These are remained on the surface, on the outer surface of the other molecules that is being adsorbed. Okay, surface phenomena. It is a surface phenomena. It is rapid in start but slowly decreases. Silica gel absorbs water. Okay, the picture is here drawn is that three molecules are attached on the outer surface of a molecule, and this is called adsorption. Next, in our slide number 9, this is about mechanism of adsorption. Adsorption is a surface phenomena. It arises because of unbalanced forces on the surface of solids and liquids. The surface is under tension due to unbalanced forces. It is about that how adsorption takes place. As we know, it is a surface phenomena. Then it is arises due to unbalanced forces on the surface of solids and liquids. Surface is under tension due to unbalanced forces. Surface of the solid or liquid tends to satisfy their residual forces by attracting and retaining the molecules of other species when brought in contact with them. Okay, it is in the picture it is mentioned that the surface layer has some molecules of liquid, and then on this liquid molecules on the upper surface there is an air. So the forces of attraction of air and liquids are different, so that the difference forces, unbalanced forces on the surface of solids and liquids uh, cause the adsorption. When these surface of solid or liquid tends to satisfy their residual forces, when they tend to satisfy by attracting and retaining the molecules of each other, and then when attraction takes place, then the molecules are brought in contact. Okay, let's go over slide number 10. It is about types of adsorption. First type is a physical adsorption. Van der Waals attractive forces present in this physical adsorption. It is also referred as van der Waals adsorption For example, adsorption of hydrogen or oxygen on charcoal is physical adsorption, because in this adsorption there are van der Waals forces of attraction. Means that van der Waals forces, attractive forces, attract the molecules of hydrogen on the charcoal, attract the molecules of oxygen on charcoal. Okay. The other is other type of adsorption is that chemical adsorption or chemisorption. Chemical adsorption is due to chemical bonds. Chemical bonds, covalent bond or ionic bond in nature. Example is given that if we attach hydrogen on the nickel, when we attach hydrogen on nickel, then it is attached on nickel by chemical bonds or chemical adsorption or chemisorption. In the diagram it is written that physical adsorption and then other is chemisorption, mean chemical adsorption. Okay. In the physical adsorption, one thing is mentioned that the bond in hydrogen is not broken. But when we talk about chemisorption, the bond in hydrogen HH bond is broken and the new bond are found with nitrogen. Nickel. New bond are found with nickel and the bond with hydrogen are broken in the case of chemisorption. One line is written on the left side of slide is that in the green line it is that often adsorption is a combination of two types of adsorption stated above. Okay, it is written that the adsorption is a combination of two types of absorption. Number one is physical, number two is chemisorption. Let us go to slide number 11. This slide is about factors affecting adsorption. First factor is that adsorption and surface area. That what is its effect on the adsorption? Adsorption being a surface phenomena, we know that adsorption is a surface phenomena. The extent of adsorption depends on the surface area. If we increase in the surface area of the adsorbent mean the solid. If we increase the surface area of the adsorbent, then it will increase the total amount of gas that is being absorbed. It means that adsorption will be greater. Surface area and absorption have a direct relation. Second factor is nature of gas. Generally more easily liquefiable a gas. It means that if a gas has a tendency that to go liquefied easily, it means that higher its critical temperature. If we increase its critical temperature, then what will happen? The more readily will it be adsorbed. It means that if we increase its critical temperature, the higher will be its critical temperature, the more easily it will be liquefied. The more easily gas will be liquefied and more easily adsorption will be take place. Next point is that 1 gram, we have an example that if we take 1 gram of activated charcoal and it adsorbs 380 ml of sulfur dioxide, critical temperature will be 157 degrees centigrade, and 16 ml of methane having critical temperature minus 83 degrees centigrade, and 4.5 ml of hydrogen having critical temperature minus 20 degrees centigrade. In these cases, the critical temperature is being reduced from 157 degrees centigrade to minus 20 degrees centigrade. If the critical temperature decreased, then adsorption will be decreased. Next point is that third factor is heats of adsorption. Heat, okay, basically heat is energy liberated or energy exhaled, means energy given out when 1 gram mole of a gas is adsorbed on solid. Basically this is the heat of adsorption. In physical adsorption, gas molecules concentrate on solid. Physically, gas concentrate on solid. Thus, it is similar to the condensation of a gas to liquid. Therefore, adsorption, like condensation, is an exothermic process. So, it it liberates heat. This is called heat of adsorption. It is about effect of temperature. The fourth point, effect of temperature, is that adsorption occurs rapidly at low temperature and decreases with the increasing temperature. Okay. Fifth point is that heats of pressure. The more increase in pressure leads to increase of adsorption, and decrease of pressure causes desorption. Next is reversible character. Reversible character is basically a physical adsorption is a reversible process. Thus, when gas changes into gas or solid changes into gas, and if gas is adsorbed on solid, then it will liberate heat. Chemisorption, on contrary, is not reversible because a surface compound is formed. Okay, the equation is written. It shows that it is exothermic process. The last factor is that thickness. At low pressure, the physically adsorbed gas forms only one molecular thickness layer. However, above a certain pressure, multi-molecular thickness layer is formed. Next, slide number 12. Adsorption isotherm, the relationship between extent of adsorption and equilibrium pressure. If the adsorbate is gas, or equilibrium concentration if the adsorbate is a solute in a solution of adsorbate at constant temperature is known as adsorption isotherm. The graph is shown here, adsorption isotherm. In the x-axis we have some pressure and concentration, and in the y-axis we have the adsorption unit, mean per meter, which adsorption, how much adsorption it is occurring. As we increase concentration, the adsorption becomes greater, but at higher concentration or pressure the absorption remains constant. Okay, let us go on next slide number 13. Types of adsorption isotherm. First is Langmuir isotherm, second is Freundlich isotherm, third is Temkin isotherm, fourth is Dubinin Radushkevich DR isotherm, and the fifth is Brunner, Emmett and Taylor, means BET, BET isotherm. We will discuss only the first two, Langmuir and Friendlich, in our next lecture number 10. So this was our lecture number 9. Okay, thank you so much, dear students. Any question regarding to this lecture, you can ask freely. Allah Hafiz.